Thank you very much. Thanks for the organizers' invitation and opportunity to present our work, and thanks for your patience to all the audience. I would like to directly go into results and hard facts given the short time I have. We have been talking about different SDGs and disconnect and connectivity and synergies between them. So my colleagues looked into coffee production in Uganda, and they could find that agricultural activity can contribute to these SDGs. And the gray areas are the potential contributions in each SDG that agriculture can make. So just to give an impression, not to present the results, but just how interconnected agricultural activity is being the primary anthropogenic activity of human beings. Now, we know the challenges in developing parts of the world. So soil degradation, climate change, small-scale structures, these are influencing the smallholder farmers, which supply, till 80% of the farmland in sub-Saharan Africa and Asia, so supplying most of the food. That was already said this morning. When we look at the availability of data, there are several meta-studies, but most of the data points are located in North America or Europe. So there is very limited field data on the performance of different agricultural production systems in the South. So from Asia or from Africa, there is very limited information available. We, from FiBL, the Research Institute of Organic Agriculture, located in Switzerland, we are running a couple of projects all over the world. And I'm from the Department of International Cooperation, so we have all the projects in developing countries. I would like to mention two projects and quickly present the results of one of them. One is the systems comparison, long-term farming systems comparison, which we are doing since 2007 with permanent field locations in Bolivia, India, and Kenya. It's a farming systems approach with different crops, but there are like some key cash crops in each country, like cacao in Bolivia, maize and vegetables in Kenya, and cotton in India. Then these are the on-station research trials with permanent researcher-managed field sites. Then we have two projects called Pro Eco Africa and OFSA, where we study the on-farm fields of the farmers, organic and conventional farmers, how they perform. We have studied them over several years now. So I will not present the results from this study. Now, these are our three sites in India. The first one in India, this is the long-term trial. This is how it looks like. Then in Kenya, we have this field site with high input, low input farming systems and organic and conventional systems. In Bolivia, we have agroforestry and monocultures, both in organic and conventional systems. So our basic idea is to compare the conventional system of production with agro-ecological or organic forms of production. So now I would share some results from these trials. We have seen from our data from Kenya, in 10 years, organic high input systems, they have increased the carbon quite significantly, whereas conventional systems did not, and even the organic low input system did not increase because there are very little inputs into this system. So it's not only if you are going organic way or conventional way, it is how much of which inputs you are bringing to the soil, or what is your management of crop residues and all that. So it's the holistic management of the system which is very influential on soil. Then we see from India, this is data of 7 years. So you see in biodynamic and organic systems, which are more or less comparable, we have seen an increase in organic carbon in the soil, whereas the increase or change in conventional and BT conventional systems is not significant. And I must say that in this case, we are also adding manures, so organic manures to conventional systems because of the local practice of the farmers. But this is much less than the organic systems. In Bolivia, we see that agroforestry systems, they retain more carbon in the soil compared to conventional systems, naturally because of the litter fall from the trees is quite a heavy input into the soil. So that is quite a sustainable system. Then we look at biodiversity conservation. So in India, we have seen that the biomass and also the number of earthworms was much higher in organic systems, and earthworms are called engineers of soil. So they help build soil fertility by breaking down the organic matter. So this is quite a significant result to see that the organic soils are much more live than conventional soils. In another study on the same field site, we found that organic soils were capable of supplying phosphorus to the plants comparable to the conventional ones, where in the conventional ones we put synthetic fertilizers of phosphorus, but not in organic ones, simply because organic soils were more live and biologically active. Then in Bolivia, we saw that there were much higher number of species and higher individuals of each species of birds in the agroforestry systems. There is a fallow system, which is more or less like an outgrown forest. So there, of course, the birds were much more diverse and much higher numbers. So agro-ecological systems, of course, preserve and conserve biodiversity. For crop yields, in Kenya, we see that the yields of maize in organic and conventional systems are equal, because yields is a big debate when coming to organic and conventional systems. We see that the potato yields were significantly less, and the green bean yields were also less. One key reason here is the pest control. There is a significant, huge attack of pests in organic plots, which is not addressed yet. We are working on addressing it in Kenya. We have addressed it very well in India, but in Kenya we are still lagging behind. If that is addressed, the yields of vegetables and green beans and these things could be improved much better. In India, this is the yield development through from 2007 to 19. For cotton on the left and soybean on the right. So soybean yields are consistently equal throughout this period. Every year, each year, organic and conventional crops, you can produce equal amounts of soybean with much less resources input into organic systems, simply because soybean is a legume and it can make its own nitrogen. So nitrogen is a big thing in while addressing the production systems, and legumes, it is well known we can produce quite good without synthetic inputs of nitrogen. In case of cotton, there are years where we have comparable yields. There are years where we have lower yields. One key factor is the attack of the cotton bollworm, because in the conventional BT plots, we grow genetically modified cotton, BT cotton, which is resistant to the bollworm, and in the organic treatments, we grow a similar variety without the BT gene. So this is one of the reasons, and this needs to be addressed. The other reason is nitrogen supply in some of the years, but the yields are not that different in organic and conventional systems. The same thing here, this is the average yield. So in the previous slide, this was the progression of the yields, and this is the average of 10 years. And here we see, again, the soybean yields are same, there is a difference in the yields of wheat, and there is some degree of difference in the yields of cotton. Now, if we go for the average gross margins, that is what a farmer will get after deducting the costs. The gross margins in some cases, like in soybean, organic gross margins are higher. In cotton, they are either statistically similar or slightly lower. In case of wheat, the gross margins are lower. But the picture changes when we think about return on investment. So for the smallholder farmers, return on investment is very important because they have very limited capital to invest. So in case of organic, the return on investment is much higher in all cases, despite lower yields. So organic and agroecological approaches offer a good alternative to smallholder resource-poor farmers. Now again, these are the crop yields from Bolivia. Here we see on the left 2 bars, they are monocultures in conventional and organic, then agroforestry systems, conventional and organic, and then there is a successional agroforestry system where we have different crops in different strata. So we see that, so the solid bars are the yields of cacao, and the dashed ones are the yields of banana and plantain, which was initially intercropped in the monocultures because the cacao plants were small, and in agroforestry they are continuously cultivated. So plantain and banana, they offer much higher food production in these agroforestry systems together with the not too low yields of cacao compared to monocultures. And so this is a good continuous return to the farmer, so economic benefit, food benefit, and then interesting thing is about the successional agroforestry systems where you get a range of different food products produced throughout the year. So that is very important for the family nutrition of the smallholder farmers. If you in the next slide, we will see for the successional agroforestry systems, they have much higher nutrition potential compared to both monocultures and agroforestry systems. Then is again the profitability in Bolivia. You see the revenues in dollars. So conventional monocultures, of course, produce more revenues because of the export of cacao. But the costs, without including the labor costs, are also much higher in conventional production. Then when you add the revenue from other crops, the picture changes. So this is when you only account a commodity, export commodity, but when you account other crops, plantain, banana, and other things, the picture is different. So one lesson is we should not go only into the commodity trade and commodity-based incomes. One important finding is that the return on labor is much higher in agroforestry. So 1 day of labor spent by a farmer in agroforestry is much better than spent in monocultures. Resource use efficiency, we saw that the cumulative energy demand of non-renewable resources was much higher in monocultures than agroforestry systems, the solid bars you can see. And then from all these discussions, we see that there are some disadvantages. There is no silver bullet in some crops, particularly cereals. We see lower yields in certain cases. We still need to address things. But for biodiversity conservation, for soil fertility, for productivity and profitability, organic offers a good solution to particularly to the smallholder farmers. But there are still challenges. From the total research budget of food and farming systems, less than 1% go to agroecology or organic practices. And with a legacy of over a century of conventional agriculture, I mean, this is incomparable. The technologies that we need to develop in organic would need much higher investment into the development of these practices. And the one point I want to make is that now Eurostat results, they present that the surface of organic agriculture has increased in Europe, addressing the SDG number 2.4.1, but that is not yet included in the development policy. So increasing the surface area in the developing world under organic and agro-ecological practices, in my understanding, is not part of the development policy. So that is one of the things which probably could be valuable for the next process in development policy. To get more results, please log on to our results. I think this presentation will also be available. Thank you very much. This work was done with the support of our donors and partners. Thank you.